General Math students, in this video we're going to be making some predictions using the graph and equation. So the data we have here is for a poultry farmer who's been administering hormones to chickens. The more hormone that's administered, the bigger the bird. Okay, so the data is shown here in a table and on the scatter plot, and they're also showing us the regression, so we don't have to go ahead and find that. They've done that bit for us. Here is the line for that regression. Okay, that's the line of best fit for that regression. So we're going to use that line and the equation to make these predictions. So the first one in part A asks us to use the graph to predict the weight of a bird if it was given 14 grams of hormone. So we're going to get the ruler out. We're going to line it up on 14. So this scale's a little tricky. It's not too bad. 12, 13, 14. I reckon 14's right there. I'm going to get a pen and I'm going to rule up to the line of best fit until I hit it. And then I'm going to rule across from there to the y-axis. Just go up a little. Doesn't want to do it for me. I'll just go here. Let's see how that goes. Probably want it a little bit higher than that. It doesn't want to do it. Let's see how this one goes here. That's better. Okay, I'll go across from there. Okay, so we get just above 2.2. This is going up in 0.2s on this axis, so that's 2.2 right there. So it's just under 2.3. I don't know, maybe say 2.25, something like that. Kilograms. All right, so let's check that using the equation. So the equation, it always gives a more accurate answer, not necessarily a more reliable answer, but a more accurate answer than the graph. The graph can be a little less accurate. Okay, let's use the equation. So we're going to substitute into this equation now. I'm just going to use W for weight equals 0.068. Now H this time is the amount of hormone, so H is equal to 14 grams. So I'm going to put a 14 in for H. So we're substituting 14 into the equation. Okay, so now we'll do that one on the calculator. 0.068 times 14 plus 1.375 gives 2.327. Okay, so quite close to, I said 2.25, that rounds to 2.3 if you go to one decimal place, and so does this. So the exact answer that was predicted is 2.237 kilograms. Righto, so let's look at the next one. You might want to pause the video at this stage and have a go at this one yourself. So in this case, actually, we're going back the other way. All right. So we're told that we're asked how much hormone would be required to raise a 1.8 kilogram bird. Okay. So we're actually looking at the dependent variable, the y variable, making a prediction of the x variable from the y variable. Okay. So I'm going to go and line up my ruler at 1.8, which is right here. Okay. I'm going to get the ruler and line it up on the line and go across with the pen from 1.8 until I hit the line. Then we're going to switch it round and go down to the x value that corresponds with that. So we're right about here. That's not bad. I'm going to go down there, and my prediction from the graph is about 7, I'd say. Remember, 6, 7, 8, 9. It's about 7. So 7 grams of hormone. Okay, let's check using the equation. So this time we're going to need to do some rearranging because we're substituting onto the left-hand side. We're putting in a value for the weight, right? So W equals 1.8 kilograms. So we put that Y variable in, 1.8 equals 0.068 H plus 1.375. So now to rearrange this, we need to bring the 1.375 over first and then the 0.068. So they're going to do the opposite on the other side to what they're doing on this side. So this 1.375 is going to come over and become the opposite of plus, which is minus, so negative 1.375. And the 0.068, now what's that doing to H? What mathematical operation? It's multiplying. So on the other side it will divide. Okay, so essentially what we have is that H is equal to, and we have the 1.8 minus 1.375 divided by 0.068. So see, we're subtracting the 1.375 and then dividing by the 0.068. So let's work that out on the calculator. And we get 6.25. So I said from the graph that it was 7 grams. Oh, it's a little bit off, but not too bad. 6.25. So that's a much more accurate prediction. Like I said before, not necessarily reliable, but more accurate. Okay. All right, so last one here. Use the graph to predict the weight of a bird if it was given 22 grams of hormone. Okay, now I'm going to line this up over here. Just get this one out of the way. Now, what we'll see here, that one doesn't want to get out of the way, just bear with me. Okay, what we see here is that 22 grams is actually kind of, well, it doesn't even hit the line of best fit when we start to line that up. So I'm going to have to extend my line of best fit. It's leading into this idea of extrapolation. We're actually extrapolating this result because the data doesn't go up that high. All right, so I'll just extend my line of best fit so we can actually make the prediction, which is outside the bounds of our data. So extend that line of best fit a bit. Okay, now 22 grams of hormone. I'll pop him there. That's close enough for me. We'll go across, up rather, and now across. I would say it's pretty much on that line exactly, isn't it? Like right, whoops, don't do that. Bear with me for a sec, I'll get there. Okay, pretty much right on that, we'll say. So what's that telling us? 2.8 kilograms. All right, so let's use the equation. Now we're substituting back in for H, back for the X variable, so no rearranging required. W equals 0.068 by 22 plus 1.375. Okay, so we'll check that on the calculator. And that gives us 2.871, pretty close. That would round to 2.9 for one decimal place, but 2.9, 2.8, not too far off. So 2.871 kilograms. Now, The next question here, we're not going to cover this in this video because there's quite a bit about reliability which we'll cover in another video, but it goes into that idea that I was talking about where this last prediction that we've made isn't in the data that's been tested. All right, so we'll talk more about that in a subsequent video, but for now, go ahead and try some questions where you've got to make some predictions.